Hello and welcome to all in this video lecture series on 8051 microcontroller. We are discussing hardware interfacing with 8051 microcontroller. In some of our previous video session, we had discussed how to interface relay module with 8051 microcontroller, then 0804 ADC interfacing, 0808 again ADC interfacing, and at last we have seen the DAC, that is digital to analog converter interfacing with 8051 microcontroller. And in this today's video session we are going to talk about interfacing a DC motor with 8051 microcontroller. Okay, so here in order to interface the DC motor with 8051 microcontroller, we are rely on the motor driver IC, and that is known as L293D, right? So we are going to discuss the logic to interface the DC motor with 8051 microcontroller. In the sense, we are much more going to talk about how to interface the DC motor with 8051 microcontroller through this motor driver IC, that is L293D. So let's begin. So when we talk about the DC motor interfacing with 8051 microcontroller, as we know that the maximum output current of microcontroller pin is 15 milliampere at plus 5 volt supply. Okay, means a single port pin, that is from whatever this P M dot N is there with us. So from that, where M is equal to 0 to 3 and N is equal to 0 to 7. Okay, all these pins are capable to provide the current of 5 milliampere at what? At voltage plus 5 volt, right? So the power requirement for most of the DC motor is out of reach of the microcontroller, right? Means in order to drive this DC motor efficiently by this microcontroller, whatever the current that supplied is not enough. Okay, so that power requirement for the most of the DC motor is out of the reach of this simple what we call the microcontroller. Okay, so the back EMF, that is electromotive force, that may or that is generally generated during this motoring action in DC motor, will produce the damage, or whatever this back EMF that produced by the motor may going to damage the microcontroller board here. So to overcome this, it is not good to interface DC motor directly with 8051 microcontroller. For example, say this is my DC motor and I am going to interface directly this with the 8051 microcontroller. Right? The certain limitations are there. What is the first limitation? The current requirement. Right. So the current requirement for the DC motor is not fully satisfied directly by this 8051 microcontroller. And even when if we try to do the same, right, whatever the back EMF that is generated by this motor is going to damage or may going to damage the 8051 microcontroller board. So we can't, or it is not good practice to directly interface this DC motor with 8051 microcontroller. And in order to tackle this situation, right, what we are going to do, we are going to rely on motor driver circuit, and that motor driver circuit is connected in between your DC motor, right? So I will represent over here. So this is there with me. So instead of connecting the DC motor directly with 8051 microcontroller, what we are going to do, we are going to make use of this motor driver circuit, okay, in between 8051 microcontroller and DC motor, right? So this is a basic need of it. First is what? To satisfy the current requirement, and second, to protect the board from the back EMF that generated by the DC motor. In order to deal with these two situations, what we are going to do, we are going to make use of this motor driver circuit here, right? So to drive the DC motor, L293D and L298N, these motor driver ICs are used. For L293D motor driver IC, the motor supply is variable between plus 4.5 volt to 36 volt. However, the maximum current that supplied is what? 600 milliampere. So just try to get this. If we are going to make use of microcontroller, the single port pin is capable to give only 15 milliampere current. However, if I am going to make use of this driver circuit is capable to give the maximum current up to 600 milliampere. Okay, and because of that, here whatever the motor current requirement, power requirement is there, that will be fully satisfied through this motor driver IC. So these are the two options there with us, L293D, and the second one is L298M, right? So when I'm going to talk about L293D, the voltage supply range for the motor is between 4.5 volt to 36 volt. However, it is capable to deliver a current up to 600 milliampere. However, if I am there with a maximum current requirement, I am simply going to rely on this L298M, right? So where the motor is supply up to 36, which is surely greater, so 36 volt, greater than that of L293D, and the current that it is going to provide is what? 3 ampere. Okay, so where we are dealing with the high rated applications, we may go with this L293D, right? So here, when we are going to talk about any automation activity, or I will say as a robotic activity, we require what? The interfacing of L293D with that of, say, simple or the DC motor interfacing, which we are the central controlling unit, and that can be do through this motor driver IC. So let us talk about L293D, the motor driver IC, right? So this is a pin configuration. This is basically a 16-pin IC, right? So the same its implementation, or it's what we call the equivalent IC implementation, which is present in Proteus library is shown here, right? Here, so it is, as said, 16-pin IC, which is going to say generally we are going to give the plus 5 volt supply to this VCC 1 pin. Okay, so here if you see, we are there with this different configuration. The one configuration I will say as a input 1, input 2, output 1, output 2. And similarly, if you focus over here, then we are there with what? Input 3, input 3, input 3, input 4, then simple output 3 and output 4, right? So what it indicates, a single IC is capable to drive two DC motors simultaneously. Just try to get this. A single L293D, this motor driver IC, is capable to drive the two DC motors. So one DC motor need to be connected between this output 1 and output 2. However, the second DC motor is generally connected between output 3 and output 4 in this way. And the controlling action, that means to what we call that, run that motor either in clockwise or anti-clockwise direction. So that controlling action for motor 1 is given from input 1 and input 2. However, for motor 2, it is given from input 3 and input 4 here. So just try to get this. Here, this configuration, input 1, input 2 deals with motor 1, whereas the input 2, input 3 and input 4 deals with motor 2 here. Okay, with the controlling action is given from input 1, input 2, input 3, input 4. Okay, and the motor is actually connected between out 1, out 2, the first motor, and out 3 and out 4 for second motor. Right. So here, this controlling action, that is input whatever given here as shown, input 1, input 2, input 1, input 2, input 3, input 4. This is basically given from where? From this 8051 microcontroller. The port pin. Through the port pin, we are going to give the controlling signal. Right. So here, the pin number 4 and 5, this is ground, which is grounded here, and again the pin number 12 and 13 is grounded here. Right. Now the most important here. This VCC2, the VCC2 is generally depends on your motor supply. Generally, if you are going to make use of that plus 12 volt DC plus 12 volt DC motor, this VCC2 pin is supplied with plus 12 volt. However, the VCC1 is going to work as biasing for this IC, which is generally connected to plus 5 volt here, right? Okay, so this is a generalized configuration. Now the most important one, that is what enable 1, 2 and enable 3, 4. Enable 1, 2 means what? In order to enable the input 1 and 2, enable 3, 4 means what? Enable input 3 and 4, right? So, even though if I am going to give the proper connections here, means I am going to say make this pin 1, this pin 0, this pin 1 and this pin 0, right? Both these motors are supposed to run in clockwise direction. So, even though if I am going to provide a proper signals here, the voltage level here, unless and until this enable pin are made high, right here, the motor won't run. Means simple, to enable the input, generally the pin number 1 and pin number 9 is used, which is nothing but what your EN1 and this EN2, and you may connect this to 8051 microcontroller and directly make this pin high, or directly connect this to plus 5 volt supply, which is seems to be like a best practice. Always connect directly this to plus 5 volt supply. Okay, so when I'm going to talk about this L293D, the L293D is a H bridge motor driver IC. This IC works based on the concept of H bridge. Okay, so the H bridge is a circuit which allow the voltage in either direction to control the motor direction. Right? So there are 4 inputs, just we have studied. The motor direction depends on the logic input applied to this pin, means the way in which we are going to give. Suppose here this pin, this signal is equal to 0, this is 0, means I will write here, say this is my input 1, which is going to input 1 and input 2 going to control motor direction of first motor, say for M1, and for M2 suppose here the input 3 and input 4 is there. Okay, so when I am going to talk about it, when both are equal to 0, the motor is there into idle state, means they are into stop state. Okay, so I will say here this is what simple the stop. When the input 1 is high and input 2 is 0, the motor works or run in clockwise direction. However, if this bit is equal to 0, this bit is 1, it is going to work in anti-clockwise direction. And here if I am going to make is 1, this is in the idle mode, means it is same as that of your simple your stop condition. Right. So this is very much important to control the direction. If you want to run the motor in forward direction, make the input 1 high, input 2 low. If you want to run the motor in anti-clockwise direction, make the input 1 low and input 2 high. And the same is true here. So 0 0, this is stop. 1 0 clockwise direction, 0 1 anti-clockwise direction, 1 1 again the stop. That is what the right. And as simply said, the EN1 and EN2 must be high to drive these two signals. Okay. So this is what we call as the generalized implementation of your L293D. So let us consider one simple example. Right. So this is my interfacing diagram. So as per my interfacing diagram, what we are going to do, the two motors are connected here, right? So the out 1, out 2 deals with motor number 1, out 3, out 4 deals with the motor number 2. The VS, that is the pin number 8, is supplied with plus 12 volt. The VSS pin number 16 is supplied with plus 5 volt. And we are going to make this enable 1, enable 2. We are going to connect this directly plus 5 volt supply. Okay, so that what will happen, continuously my input is there into enable, right? So simple. The P1.0, P1.1 going to control the direction of motor 1, and P1.2 and P1.3 going to control the direction for motor 2 here. Okay, so when this bit is 1, I will write here, suppose this bit is 1, this bit is 0, what will happen? The motor 1 will run in clockwise direction, and if this bit is 0 and this bit is 1, it run in anti-clockwise direction. And the same is true for what? This motor 2 here, right? If this bit is 0, second bit is 1, it is going to run in anti-clockwise direction. Whereas if my first bit is 1 and this bit is 0, it is going to run in clockwise direction. So this is a simple and straightforward logic that we are going to implement in Kyle IDE and going to give its demonstration in simple property simulation software, right? So what we are going to do, first we are going to run both the motors in clockwise direction, wait for some time, and again run both the motors in anti-clockwise direction. So let's see. So consider this program. As said, the first input, input 1 is connected to P1.0, second input, input 2 connected to P1.1. For second motor, the first input connected to P1.2 and the second input of motor 2 is connected to P1.3 here, right? So these are the connections simple. As we are going to send a signal from microcontroller to motor driver IC, all these port pin, that is port P1, is configured as a out. Then simple, this while 1, And now I'm going to rotate the motor in clockwise direction. And in order to rotate the motor in clockwise direction, we have seen the first input is 1, second input 0, again first input 1, second input 0. The same task we did here. First input 1, second input 0. For motor 2, first input 1, second input 0. Then we are providing a delay. So the motor will run in clockwise direction for the amount of delay provided. Then I am going to stop the motor. So for that, all the port pins are made 0, again some delay, and then to run the motor in anti-clockwise direction, first input 0, second input 1, third input 0, and last input is 1, right? And again just call this delay. So in this way, we are going to rotate the motor in simply clockwise direction and anti-clockwise direction. So here I am going to run the code, right? And now just check out the output. So here we did this implementation. Now I am going to run the program. So just check out here. First, the motors are rotating in clockwise direction when it is 10, 10 is there with us, and going to stop for some amount of time, and again it is going to reverse its polarities, and in response to that the motors are running to the anti-clockwise direction. So simple. By controlling the directions of these pins, we can make the DC motor to run either in clockwise or in anti-clockwise direction. So in this way, simple, we can interface the DC motors to this 8051 microcontroller through L293D motor driver IC. Now let us consider, we are going to put the two switches here. The first switch I am going to connect to P1.4 and the second switch I am going to connect to P1.5. And what I want to perform here, when I am going to press the first switch, both these motors should run in clockwise direction, and when we are going to press the second switch, both these motors should run in anti-clockwise direction. So let us develop a code for this. So as mentioned, S bit say button 1, B1 is equal to P1.4, the first button I can say, and the second button is P1.5. Okay, so this is button 2. Now the things are some little bit of change. Here the first 4 pin, that is P1.0, 1, 2, 3, these are going to work as output, whereas these 2 pins are going to work as a input. The moment at which I am going to press the switch, the status of the pin is get changed from high to low, and in response to that, the both motors should run into clockwise direction. And when I am going to press the second switch, both these motors should run into the anti-clockwise direction. So let us check out its execution. So here the change is there is what? First of all, I am going to change the status. If B1 is equal to 0, what we have to do? We have to run both the motors continuously into clockwise direction. Okay. So for that, this get changed. And if B2 is equal to 0, what we are supposed to do? Both these motors should run in anti-clockwise direction over here. Okay. So now just check out the execution here. So we will in execution. Right. So initially no switch is pressed, the motors are there in idle state. Now I am going to press the switch. So the moment at which I press the switch, both motors are running in clockwise direction. Okay. And when I am going to press the second switch, both these motors are going to run continuously into anti-clockwise direction. So here, as per the requirement, we can change the directions of both motors depending upon the implemented buttons. Right. So this is a way by which we can interface simply the DC motor through motor driver IC L293D.